Okay, so now that we know what lexical access is and how it can be impaired in aphasia, let's now turn to healthy brains and ask what we've learned from non-invasive monitoring of activity in the healthy brain about the brain correlates of lexical access. And I'm going to focus on electrophysiological evidence because, again, it gives us the time resolution to actually kind of pinpoint a specific level of processing or a processing stage in neural activity. So we've already looked at examples of a person lying, in this case, the MEG machine. We're interested in the electrophysiological response to a word. So for example, a written word like table here. And the question I want to ask here is how we can sort of find lexical access or neural correlates of lexical access from these squiggles that we're looking at here. And the answer for how we can find lexical access in this kind of messy looking picture is by making lexical access either hard or easy. And then we see what kind of changes in the electrophysiological signal. So we try to vary the properties of lexical access, how hard it is for the brain to activate a word, and then we see what changes in the signal. That's the basic idea. Okay, so how can we make lexical access easy or hard? How can we vary this process? Well, the ease of accessing a word or a lexical entry, as I'm calling it here, it always depends on the level of activation in that representation right before you're trying to access it, okay? So if the word hasn't been used in a long time, its representation is not very active. It's kind of a sleepy representation. And when you try to access a word like that, it takes you a little bit longer to do that. It's just a slightly harder process. But if you use a word a lot, if it occurs a lot in your language, you constantly have to kind of use it in your language, then that representation is more active and it's easier for you to access it. That's kind of the basic idea. So the general alertness level of a lexical entry depends fundamentally on how often we use it. And that level is what we call the resting level of activation in an entry. So it's kind of a theoretical term where we're talking about that. What's the kind of default activity level of that representation? And by the frequency of the word in the language. And here you might immediately have this thought that, well, the frequencies of words must be very different in different people's brains. And, you might have, expertise in a specific domain like knitting, and you know a lot of knitting words and you use them a lot, whereas the non-knitter totally doesn't use those words at all. And so while that is true, it turns out that at large, there are robust generalizations about the kind of frequency levels in our mental lexicon, such that in experiments we can get pretty consistent results. So a frequent word almost in everybody's brain is something like time. It's a very frequent word. So that representation is pretty active at all times, whereas less frequent words like mar, for example, probably quite infrequent for most people, is just a much less active representation. So the resting level of activation is just much lower for mar than for time in most brains. Okay, so let's go back to the lexical decision task then. So remember, this is the task where you are presented with let's just say the visual modality with strings of letters, and some of them are words and some of them are not words. So home, yep, word, you would press the yes button. Loam, not a word, no button. Null, not a word, no button. Stand, yes, a word yes button. So that's a basic behavioral task that has been used to study lexical access for a really, really long time. It's the most common task that we've used to study this process. And so now if we vary frequency in this kind of a task, so for example, here's 6 categories of frequency: number, very frequent word, and then it goes down in frequency step by step. So ask is a little bit less frequent, wheel, candle, clam, snarl, very frequent, infrequent. And we look at people's button press times for them to say, yes, that's a word in my language. We see a very nice, very linear effect of frequency. So your reaction times gets longer as you get to the less frequent categories. So now, armed with this kind of behavioral data, we can ask the question if we can find something in the brain that would kind of mirror this effect. So if this effect is really showing like your effort of activating that lexical entry, then maybe if we vary frequency, we can identify that neural activity. And that's exactly the kind of experiment that people have done. So now, in addition to having the person press the button, you would measure their electrophysiological activity millisecond by millisecond. And so that's the really nice thing about these techniques. And so now if we do that and we present the subjects with, say, visual words, like in this case, then we get this characteristic response that we already looked at in the context of when we were talking about reading. And so when we talked about reading, we saw evidence that at this M170 level of processing, there is activity in the visual word form area, and that seems to contribute crucially to our reading process and our ability to read. So now we can ask the question, well, what about the lexical properties of the stimuli? Say like the lexical frequency of what you're encountering. At what point in this processing stream would that have an effect? And it turns out that that stimulus variable consistently has an effect at this, what I'm calling the M350 component. So this is activity between 300 and 400 milliseconds. Pretty consistently seen in MEG, which is the technique that we're looking at here. And this activity, for example, shows a lexical frequency effect among other variables that affect lexical access. So for example, from that same study that I was showing you data from earlier by Embick and colleagues, 2001, they also measured the peak latencies of this M350 component. So it's like a kind of a consistent component, and they were looking at what point in time does that activity peak. And what they saw was an effect of frequency, not quite as pretty as the behavioral effect, but nevertheless, just like the behavioral response times, the latency, the time at which this activity peaks, got longer when the words were less frequent. So it plausibly reflects some aspect of that lexical activation process. So now looking at the characteristic magnetic field distribution of the M350, we can reason, and it's supported by actual localization results, that there should be an underlying current. So remember, we're applying our right-hand rule that is pointing downwards in the left hemisphere. And so now, if that's the case, then if we were measuring this activity with EEG, we would expect to see a negativity on top of the head. So if it doesn't totally compute for you, go back to the methods slides that we went through earlier. And so now, that would be the anticipation on the basis of the MEG data. And in fact, if we measure lexical access with EEG, in a similar time window, we do see a negativity kind of at the top of the scalp. And this type of response was first seen by Kudus and Hilliard in 1980. which is when they published the very, very influential first report of the so-called N400 response. So here I'm showing data from that original report. Here you see that there is a very, very big peak for one of the conditions, and that condition goes like this. So he spread the warm bread with socks. Okay, totally weird sentence. Okay, very unexpected ending to this sentence. Versus a much more natural sentence, he spread the warm bread with butter. Let's leave aside the middle sentence for a second. And so here we see that the sentence that has the ending socks elicits this big peak. Here, 0 is the onset of the last underlined word in the expression. And when we get butter, there is a much, much smaller activity, like maybe not much activity diverging from 0. And so this N400 response component in EEG, just like the M315 MEG, is activity that is elicited by every word. Okay, so every time you hear or read a word, this activity is elicited. When the word is very predictable in its context, like butter, this response is really, really small, like almost can't detect it. And when the word is very unexpected, that is when the activity is really, really big. And so here, the difference between those two situations doesn't have to do with the frequency of the word. Here, butter and socks, like the frequency is between, I mean, they're pretty equivalent in frequency. Instead, it has everything to do with the context. So in the first case, the context really makes you expect bread. And so here, the word spread and then especially bread, they actually already kind of give a boost of activation to the word butter. And so then by the time you actually get butter, it's almost like you're already done processing it. So activating butter is very easy for your brain. Whereas in the other case, socks is not at all activated by the prior context. It's totally unanticipated. And so when you get socks, your brain is very surprised. So, and it's kind of like, whoa, we did not know that we were gonna need socks here. And it's like a lot of digging to try to find that lexical entry. And that's kind of what we think that N400 response reflects here. And then finally, their experiment also included one more control condition, this capitalized butter. And that condition is important because it allows us to interpret the surprise effect on socks a little bit more specifically. So if we didn't have this condition, these data could be interpreted as meaning that, well, anytime you get some kind of a surprise, this N400 response is elicited. But now, because the capitalized butter actually elicits a very different type of effect, you can see this kind of downgoing deflection, so it actually goes in the opposite direction. We know that this N400 is not elicited by just any old surprise, but it potentially has more to do with semantic surprise. Okay, so let's go back to the question, how can we make lexical access easy or hard? Well, we can vary frequency, but we can also vary context. So each word activates other similar words, and activation spreads both on the basis of meaning and sound. So similar meanings are activated, also similar words that have a similar sound representation are activated. And we can affect the ease of lexical access by presenting similar words before the word that we're actually interested in. So that's what I'm calling the target word. And the effect of the context word on the target word is what's called priming. So here, this is the vocabulary that we use. The first word is what we call a prime. The second word is what we call a target. So for example, if I have a priming experiment where I use bread as the prime and butter as the target, then I would expect to get a priming effect of bread on target, of bread on butter, because bread probably kind of already pre-activates butter as a semantically similar or associated word. So lexical access as evidenced by electrophysiology looks like this. So we've learned that by 300 to 400 milliseconds after the onset of a word, lexical access seemed to be robustly activated. So we see all sorts of lexical access related effects. So that's what we call M350 response in MEG and the N400 response in EEG. They don't correspond exactly. The MEG activity is probably kind of a subset of what we observe in EEG, but this correspondence here is good enough for us. And we also know that the corresponding neural activity, so the actual firing that is generating these effects either on the scalp in EEG or on the MEG sensory space, localizes in middle to posterior left temporal cortex. And now this is very consistent with aphasia evidence that comes from transcortical sensory aphasia, as we discussed. So this is a comprehension deficit where it seems like you're not able to link the sound representations of words to their meanings. And in these MEG and EEG studies, we're finding that lexical access, when we just measure it in the healthy brains, actually does localize consistently with that. So we think that this kind of brain region is active and is sort of working on lexical access in this 300 to 400 millisecond time window. And nowadays, we don't really believe that that's the very first pass of activation through these lexical entries. It probably is the case that in most of the time we can do this process even faster. But this is what I'm showing you here is a sort of a consensus finding from the literature that's supported by multiple different methodologies. And so if you kind of know one thing about the electrophysiology of lexical access, then you should keep in mind the M350 and 400 complex and its context and frequency effects.